Hello friends, welcome to our training session on detecting the ground fault in a sensitive manner by some of the methods. We discussed the first method, around 8 sessions about first method, 6 sessions second method, and 4 sessions about the fourth method, and the fourth about the third method and the fourth method, 4 sessions. The fifth method we discussed about right now. We are in the fifth, and on the fifth sessions we discussed 2 sessions before. Right now we are on the third session of the fifth method. In this method we said that we are using the harmonics of zero sequence voltage and zero sequence current, the harmonics of these 2 components, to determine the ground fault and to detect the ground fault in a sensitive manner. And in the previous session, first session, we discussed that how the block works, starts, and what are the conditions that this operation should start. And on the second session, just we discussed that what the conditions are there that this direction characteristic should be determined, which inputs are required for direction characteristic determination, and also of when the band is determined, that which harmonics should be used. Band pass filter will allow that the output signal should be fed. And now the angle between zero sequence voltage and zero sequence current also is determined. Now our system has the angle between zero sequence voltage and zero sequence current, the harmonics, of course, the angle between the harmonics, and it has the inputs for the direction characteristics. One of the input is forward or reverse direction, that is delta phi plus or minus delta phi selection, area, that how much the area it should cover, and these 2 inputs, that is, we have here 2 inputs from zero sequence voltage and zero sequence current, of course the harmonics of zero sequence voltage and the harmonics of zero sequence current, and also forward and reverse direction. Now what will happen here, if we have these 3 inputs, it means that initially how it determines the direction, it is working that initially we have V0, and we are rotating this V0 or the reference voltage. This is our rotation angle. It is rotated by 90 degrees itself. This rotation angle is not in our control in this harmonics utilization method. Before we were changing and determining this direction also by ourselves only in another method. And here delta phi from this V reference, right now we select 2 areas, that is plus delta phi and minus delta phi. In this area, if the harmonics of our zero sequence current fall in these areas, then it will detect as a forward direction, and if it fall in this area, if the zero sequence current be in this area, that is intermediate range, so in this intermediate range the direction is unknown, and if it fall in the reverse area, it will be in the reverse area of V's reference. In these areas, it is determined as a reverse direction, and here some minimum areas, that is 1 degree in this area. This is the hysteresis area in this direction. In this area, if the I0, the harmonics of I0 be in this area, Then the direction is this n direction. We are setting this delta phi, we are setting this plus or minus delta phi as a 80 degree. So 80 degree around the V reference is determined as a forward area. We selected that, okay, what the forward area is and what the reverse area is here by this manner. We give delta phi here. And by giving that delta phi, that area is determined, and these two are the inputs. One is V reference, it is taking from the harmonics of zero sequence voltage, and the harmonics of zero sequence current is supplied. Now this block works, it determines the direction characteristic, that which direction it is and which side is forward direction, which side is reverse direction, which side is unknown direction and intermediate direction. That angle between these two, it is determined just after passing the filter without passing the threshold. This angle was determined. We discussed in the previous session how this angle is calculated. Now this angle between the harmonics of zero sequence current and harmonics of zero sequence voltage, the rotated voltage, of course, it's calculated. Actually, it is calculated with respect to V0, but V0 is rotated, and finally it calculates the angle between the harmonics of zero sequence voltage and harmonics of zero sequence current. Now, during this operation, we use a stabilization counter, this guy. Why we use this stabilization counter? Mostly in the systems, this zero sequence current, the harmonics of zero sequence current and harmonics of zero sequence voltage, they appear and disappear even during the normal condition. On that time, we should stabilize our system. We should tell our system that, okay, it was some transient intermediate faults or some transients were there. It's not a ground fault to be detected. So on the time, maybe due to the switching, these parameters appear in the system, in the network, and we should stabilize our relay on that condition, that it should not pick up. So for that, we need a stabilization counter. This stabilization counter, this one has 4 cycles, and during that 4 cycles excessive, it should be in successive manner that, for example, in 4 cycles as a successive manner, then it should be stable. This value should not change. Each one of those cycle is 10 milliseconds. Each one of those cycles is 10 milliseconds. It means, 10 milliseconds. Then totally for 40 milliseconds, in a successive manner, this harmonics of zero sequence current and harmonics of zero sequence voltage should not disappear. It should be continuously supplied to this block so that the pickup occurs. If you have not subscribed our channel, please subscribe our channel and help us for providing you more free training and educational videos. And share the video, like the video, and comment your questions if you have any in the comment sections.